Hello friends, today's topic is linear decrement analysis, LDA. LDA is also called normal decrement analysis or decrement function analysis. It is a dimensionality reduction technique which is commonly used for the supervised classification problem, and it is used for modeling differences in groups, that is separating two or more classes. It is used to project the features in higher dimension space into a lower dimension space. For example, we have two classes and we need to separate them efficiently. The classes can have multiple features. Using only a single feature to classify them may result in some overlapping as shown in figure. So we will keep on increasing the number of features for proper classification. So these are the data set, the green color में and orange color, and this is the overlapping. For example, suppose we have two sets of data points belonging to two different classes that we want to classify. And as shown in the given 2D graph, when the data points are plotted on the 2D plane, there is no straight line that can separate the two classes of the data points completely. Hence, in this case, LDA, linear decrement analysis, is used, which reduces the 2D graph into a 1D graph in order to maximize the separability between the two classes. Here, linear decrement LDA use both the axis X and Y to create a new axis and project data onto a new axis in a way to maximize the separation of the two categories and hence reducing the 2D graph into a 1D graph. The two criteria are used by LDA to create a new axis, maximize the distance between means of the two classes, and minimize the variation within each classes. Okay, इन दोनों की जो distance है वो we have to minimize, and in between these two classes we have to maximize the distance between these two classes. So it can be seen that a new axis in red is generated and plotted in the 2D graph such that it maximizes the distance between the means of the two classes and maximize the variation within each class. In simple terms, this newly generated axis increases the separation between the data DTLA points of the two classes. After generating this new axis, using the above mentioned criteria, all the data points of the classes are plotted on the new axis, and this is a some figure. This is a different class and this is a different class. But linear decrement analysis fails when the mean of the distribution are shared, as it becomes impossible for LDA to find a new axis that makes both the classes linearly separable. In such cases, we use non-linear decrement analysis. Extension of LDA, and there is a quadratic decrement analysis, QDA. Each class uses its own estimate of variance or covariance when there are multiple input variables. Second, flexible decrement analysis FDA, where non-linear combination of inputs is used, such as spline. Third, regularized decrement analysis RDA, introduce the regularization into the estimate of the variance, actually covariance, moderating the influence of different variables on LDA. These are some applications where we use LDA. Face recognition. In the field of computer vision, face recognition is a very popular application in which Each face is represented by a very large number of pixel values, and LDA is used here to reduce the number of features to a more manageable number before the process of classification. So each of the new dimension generated is a linear combination of pixel values which form a template. The linear combination obtained using Fisher's linear decrement are called Fisher faces. And medical, in this field, LDA is used to classify the patient and diseases state as mild, moderate, or severe based upon the patient various parameters and the medical treatment he is going through. This helps the doctor to identify or reduce the pace of their treatment. Customer identification. Suppose we want to identify the type of customers which are most likely to buy a particular product in a shopping mall, and by doing a simple question and answer survey, we can gather all the features of the customers. Here, linear decrement analysis will help us to identify and select the feature which can describe the characteristics of the group of customers that are most likely to buy that particular product in the shopping mall. Thank you.